Hi everybody. So I decided to split chapter 1 into two presentations. One that looked at what is psychology and the history behind psychology, and then the other, the research process, how psychology studies psychological phenomena, how we get answers to psychological questions. Now I think I mentioned before that Wilhelm Wundt, the founding father, or not say founding father, but the person who started the first psychological laboratory, you know, believed and people followed that psychology should use a scientific method established after the other hard sciences. So the components here are to identify a problem or something that you want to study, observe that phenomenon, and sometimes that might even require collecting some data, and then form a hypothesis, a judgment about how the world works. And then again, this process of testing that hypothesis, collecting more data. After you collect the data, formulating a theory, again, about how objects in the world are related to each other, and then testing that theory, again with more data, and refining your theory. And so in the end, what we end up getting is an iterative process where data informs theory, theory makes predictions, data either supports or refutes the predictions, the theory is modified, and so on and so forth. This is how much of psychological research is conducted. But it's not all experiment, and in fact much of it is naturalistic observation, case studies, and surveys, things that don't really include experiments at all. In naturalistic observation, we might just be looking for patterns in the real world and observing how people behave. Children on a playground, are they nice or aggressive? Are people in the subway? Sometimes we're interested in in-depth case studies, particularly if what we're interested in is not that common, kidnapping, or I remember in Toledo once there were some people who had this serious borreliosis, this kind of lung cancer. They spent a lot of time interviewing those case studies, those people, finding out what they were exposed to and how they were similar or different. Again, much of psychological research is conducted with surveys, a set of questions, put to participants about really anything, their beliefs, their attitudes, their preferences, the activities they engage in. You've probably all completed a number of questionnaires over the years in psychological research and otherwise. And oftentimes, these, especially like questionnaires, they don't yield an ability to make cause-effect statements. They just tell us if there's a relationship between two or more variables that are being measured, like our attitudes or our motivations. So we're not manipulating those, we're just measuring them. And here's some examples. Is family income associated with IQ? Is the height that you are associated with your shoe size? Is this level of MAO in the brain associated with thrill seeking? We just want to know if there's a relationship between these variables. And normally these yield something called a correlation, which shows you the strength and the direction of that relationship. And it goes from -1 to +1. Now in this situation, 0 right in the middle means there's no relationship between variables. Between 0 and 1, a positive, and between 0 and -1, a negative relationship. And let me explain. So something like height and weight is positively correlated. So as you get taller, you do tend to weigh more. But it's not a perfect correlation. It's not a perfect one, because we know that some people who are tall are thin, some are very heavy, and so it's not a perfect correlation. Same thing with age and health. We know as you get older, our health declines. It's not a perfect relationship. There are some people who age and have great health, other people who age and have poor health. So those correlations are usually between 0 and -1. And then sometimes there's just no relationship between the variables. Aggressiveness, not associated with height, really, and there you see closer to a 0 correlation. The great thing about the correlational research is that you can ask a bunch of questions, study a bunch of variables, and oftentimes the variables you're interested in can't be manipulated, or it's hard to. The best way for me to ask you how many cigarettes you smoke, or how you feel about capital punishment, or how motivated you are, is just to ask you. The problem is that, again, correlations don't imply causation. So it doesn't, A may cause B, B may cause A, or a variable C may cause A and B. But, again, sometimes it's the best way to assess what we want to. Now, if you do want it, and you can, if you can experimentally manipulate something, and you really want to try to make cause-effect statements, then a study is the way to go. In a study, there's usually an independent variable, a dependent variable, and some other things that we'll talk about. But the independent variable is what's being manipulated. So the aspect of the situation that I'm intentionally changing while I'm trying to keep everything else kind of the same. So I may be looking at different levels of practice. I may be randomly assigning some people to get a drug and other people to get a sugar pill. Sometimes I'm presenting a visual stimulus or an auditory stimulus. Maybe I'm modifying the temperature of the room. But I'm intentionally modifying these things to look at their impact on something. And the thing I'm looking at their impact on is the dependent variable. So this is the aspect of the situation that's measured, that changes in response to the independent variable manipulation. So the dependent variable is dependent on the manipulation of something. And my dependent variable could be anything. Again, it could be the number of words I recall, how fast I am, how much I smoke, what's going on inside my brain. You name it. It could be, it's really endless. But what happens is we get an experimental effect. So I manipulate that independent variable, and then I look at how much the dependent variable changes, and the amount of that change is called the experimental effect. And then I can make statements like drug X impairs short-term memory, or if you have people visualize, they're going to improve in their athletics, or if they practice 15 minutes, they're going to improve in their reading speed so much more than somebody practice 0 minutes, or so on and so forth. And so in experiments, you want as much control as you can. You want a group that gets a manipulation, the independent variable manipulation, a group that doesn't. You want to make sure that the people or animals, whoever's participating, are randomly assigned to the experimental or control group. No one can pick what group they're in. And when you do that, if you have rigorous control, you can make causal statements. Hey, A did cause B. The problem is, not all variables can be manipulated, and it's hard to, something that you're interested out in the real world, it's hard to recreate that in the lab. And they say sometimes these lab studies lack what they call ecological validity. Now, as you're looking at research, you always got to make sure that you're critical. And you have to ask yourself, is what's being assessed, is it reliable and is it valid? And let me give you some examples. So let's say I'm measuring IQ. Well, IQ is supposed to be relatively stable. If I develop an IQ test and I give it to you now and then I give it to you a year from now, assuming that nothing major has happened to you like a car accident or a brain injury, I would expect to see a pretty darn similar IQ. If I don't, then I would say that either the test I'm using isn't reliable or the construct I'm using isn't reliable and it changes. The other thing is the validity, and this is more this notion of, are we measuring what we believe we're measuring? So you define a construct and then you come up with a way to measure it. And let's say that I designed that a test is some way to assess anxiety. Well, I want to make sure that the questions I ask are really highly correlated with people who are anxious, but not highly correlated with people who are depressed, and a variety of other things. So again, we're looking for reliability and validity here. We have to be aware of things like response bias, sampling bias, experimenter expectancies. Sometimes we may ask questions in a way where it has a poll, that there's biased responding. People may not want to admit certain things. They may not want to admit they take certain drugs, or they engage in unprotected sex, or that they don't change their underwear, or whatever. sometimes there's not response bias, but there's sample bias. So the people that we ask aren't really representative of people that we want to generalize to. So if our sample is biased, it could skew the results. If our responses are biased, it skews the results. Sometimes even the experimenter, him or herself, has certain expectancies, and if they communicate that to the person taking part in the experiment, it can influence the results. They say the best experiment is one of these double-blind, where the experimenter doesn't know who's getting the experimental condition and the control, and the person who's participating in the study has no idea whether they've gotten the experimental condition or control. And we eliminate a lot of these effects. And part of what we really have to control for, and I imagine people have probably heard this before, are these placebo effects, and they're real. They're measurable, observable, or felt improvements, or maybe lack of improvements in health, not attributable to treatment. It stands for I shall please, but I think it goes way beyond that. I think it's more than wanting to please. It's believing that certain things will happen if you engage in take certain drugs or engage in certain behaviors. So the classic is, in all of these drug studies, some people get the active medication and some people get a sugar pill, and even the poor starch pill. But even the people who get a sugar or starch pill, you'll see changes. They will report side effects. And if it was an antidepressant, they'll report a decrease in depression. If it's a painkiller, they'll report some relief from pain. And in fact, it's crazy. I mean, I read a study where they did fake arthroscopic knee surgery, placebo, and you couldn't tell the difference between the outcomes with the arthroscopic knee surgery or the placebo. So these are really powerful, potentially powerful effects. I've never really liked this, but it does make it into this quote, but it makes a good point. Okay, there's three kinds of lies, damn lies, and statistics. But again, I don't think we should be that jaded about statistics. They have a role, but again, we need to be real critical consumers of stats. We need to understand them, the basics of them, and what they can tell us, and just be on the alert that people may use statistics to make to further their agenda. And I'm going to talk now about two types, descriptive and inferential. Now, the descriptives are just used to describe some basic features of our data. They can be very helpful, though. They give us summaries of our sample and our measures. And they can really simplify a large amount of data by saying, hey, 30% has a college education, or 50% are women, or 2/3 believe in capital punishment, or whatever. And so this oftentimes gets communicated in the form of like a mean, like an average, or a median, the most common. Sometimes they'll show us whether the data is normally distributed. Sometimes we're interested in the range of those scores. Hey, what's the highest score? What's the lowest? And are most of the scores very close to the mean, small standard deviation, or very far? All spread out all over, great dispersion, high standard deviation. Sometimes we're interested in percentiles or percents. 50% women, or they scored up to 75th percentile. All these are descriptive statistics, very useful and important. Oftentimes, though, what we're really kind of interested in doing is using inferential statistics to talk about the probability of what we're observing, whether that is related to chance or our experimental manipulation or something like that. So, we want to say, that the person who got the drug is reliably better than somebody who got the placebo. And we want to say that with a certain amount of confidence or probability. Now, in psychology and other forms of medicine, oftentimes the level of probability that they're interested in is 0.05%. So we say something is statistically significant if it has no more than a 5% probability of occurring by chance. So if I did the same experiment 100 times, 95 out of 100 I'd find the same thing. Maybe only 5 I wouldn't. And that's the level of precision that we want. Now, as we say kind of line with statistics, you also kind of have to watch the line with graphs too, and how people manipulate the y-axis. So this particular one has something to do with strategic nuclear warheads. And you kind of look over at the left and say, you say there's parity between the countries. But over here, when they shortened that y-axis, now all of a sudden it looks like, wow, the United States has vastly more nuclear warheads than the USSR. But again, they really don't. They're kind of taking the scale from 11.5 to 12. And you can do the opposite too with lengthening of the y-axis. So here, again, if you create a super high number on the y-axis, and you put something like, number needed for nuclear winter, you would draw two different conclusions. You might look at the left scale and say, wow, we have a lot of nuclear warheads. You might look at the right figure and say, wow, we don't have anything. We can build more and more. We have nothing to worry about, not even close to nuclear winter. So, again, just kind of have to watch some of this stuff. And then as far as ethics in research, we have a couple of good discussion questions about that, but know that all research has to go before an objective institutional review board. They don't allow scientists to make their own judgments now about whether a study is ethical or not. And if it has to do with people, you have to make sure you get informed consent. Do they know what you're asking them? Can they understand it? Do they know the risks and benefits? And do they agree to take part in it? We try to avoid deception whenever possible. If we do deceive people, they need to be debriefed afterwards. Listen, I didn't tell you this was the true reason for the experiment, but this is because I didn't want to change it, influence the findings, but this is what we found. Same thing, animals have rights too. You can't mistreat them, you gotta house them properly. Now again, sometimes these animals, they are subject to harm, pain, and sometimes even death. And we're going to talk about that later. So, kind of be thinking about this. Harm, is it justified in the name of science, whether it be humans or animals? Deception, this is more with humans. Should we ever deceive people as part of the research? Why or why not? And again, this is the kind of stuff that I look forward to reading in your discussion posts.